Today we will start a new topic, that is convolutional encoding. If you remember that till now we have discussed block codes. Under this context, we have discussed linear block codes and we have also seen cyclic codes. So these are memoryless encoding scheme. What does memoryless implies? That the channel encoder outputs the n bits based on the current k bits. But in convolutional encoder that has memory, on the other hand, in the convolutional encoder, the encode digits generated by the encoder in a particular time unit depends not only the block of k message digits within the time unit but also the data digits within a previous span of n-1 time units. So let us understand this with an example. Convolutional encoders are made of shift registers and modulo 2 operators. So if dk minus 1, dk minus 2 is shift register value of the shift registers, and this is the message or data bits which are coming, the output of the channel encoder is XOR of all of these three that we represent by VK1, and also the two bits that the output is two bits, VK1 and VK2, and the message bits or the data bits are coming from this side. So initially, if we assume that our channel and our shift registers has zero state. What it means? It means dk minus 1 and dk minus 2 is all 0. One point also noted down that a convolutional code with constraint length n. So this is a word you should remember. Constraint length n. A, a convolutional encoder with constraint nth L. What does it means? N. It means there are n stage of shift register. So in this example, n is equal to 3. So it is a constraint length of this encoder, convolutional encoder is 3. And number of modulo 2 adders are called L. We represent that this convolutional encoder has constraint length L and L number of modulo 2 adders. So if somebody asks what is the properties of convolutional encoder, you should ask what is this constraint length and how many are the number of modulo 2 adders. Now we come back to our example. It says that the output is 2 bits VK1, VK2, and VK1 is XOR of dk minus 2, dk minus 1 plus dk. And VK2 is XOR of dk minus 2 and dk. So this is our convolutional encoder. And if we input 11010 as a message bit or data word, then what will be the output of this encoder? Initially, if we assume that dk minus 2, dk minus 1, dk all are 0, then in that case, vk1 and vk2 will be XOR of all three or vk, and vk2 is 0. In the next time slot, what happens? 1 comes here, so dk is 1, correct? And the previous values, this will shift here, 0, 0. Now vk2 is, and vk1 is, if you see, both will be 1, because the XOR of is vk1 is XOR of all these three, and vk2 is XOR of dk minus 2 and dk. Next time instant, what will happen? In the next time instant, the next one bit will come and the previous bit will be shifted to this here. So the 1 will come here, this 1 will be shifted, 0 will be shifted, and this 0 will get out of the shift register. Then what is the value of vk1? Vk1 is 0 because it XOR of all of these three, but vk2 is 1 plus 0, that is. So if you go like this, in the next time instant, z1 will count here, z1. So dk minus 2, dk minus 1, dk, vk1, vk2. So dk minus 2 is 1, dk minus 1 is 1, dk is 0. So vk1 is all, vk2 will be 1. So this is time instant 1, time instant 2, time instant 3. In the next time instant, that is time instant 4, you will see what is happening. That dk will become 1 and dk minus will become 0 and dk minus 2 will become 1. So what is the value of vk1? Vk1 will be 0, but vk2 will also be 0. In the next time instant, what will happen? In the next time instant, this 1 will go here, this 0 will go here, 0, 1, and the input is dk will become 0, 1, 2, 3, 4, last time slab. Now vk1 is, now our vk1 is 1 and vk2 is 0. So what is the outputs in the first time slot? First time instant 1, 1. So this is the initial state. This is not the output. At the output at one time instant is 1, 1, then 0, 1, then again 0, 1, then 0, 0, then 1, 0. So what is the output? 1, 1, 0, 1, 0, 1, 0, 0, 1, 0. So this is the output when we provide input as 1, 1, 0, 1, 0, 1, 1, 0, 1, 0. So what we have seen here, that the output of a convolutional encoder does not depend only on the present input but also in the past state of the shift register. That is why it is called memory with memory encoding scheme with memory. This is not memoryless like previously we have studied block LBC and CC, that was memoryless block coding scheme, right? So what is the rate? Rate of a convolutional encoder is 1 by L. 1 bit is coming inside and L bits are coming out, so it is around 1 by 2. In this example, the rate of the convolutional encoder is half for this example, because we are using L is number of modulo 2 adders. So this is important. So what we have seen till now, that we have to construct convolutional encoder which has memory and can be made using shift register and modulo 2 adders. Number of shift registers or the is called constraint length of the convolutional encoder, and L is called number of modulo 2 adders. So these are the two proper characteristic or two elements or two parameters which defines convolutional code. And how this vk1 and vk2 are generated, this is an example that you can generate vk1 and vk2 like this. So we have seen this example, and next we will see the process of coding and decoding, how the coding and decoding can be facilitated if we use few representations of this convolutional codings. First is code tree method to represent them. Second is state transition diagram, and the third is trellis diagram. The most important is trellis diagram. We will study decoding of the convolutional codes using trellis diagram. So first, let's start with the. I would suggest to start with the state transition diagram first. Generally, in books we start with code tree, but we start with state transition diagram. So, in this example only, what we have seen, this is our present input, and these are the two states. These are the two states. Okay, these are states, and this is the current input. And the output is, first output is XOR of all the two states and the current input, and the second output is XOR of current input and the second state. So what are the possible, can we make a table like this? That what are the possible dk minus 2, dk minus 1 or dk combination? Accordingly, we can have vk1, vk2. 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, sorry, 0, 0, 1, yeah, excuse me. 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 5, 6, 7, and sorry, 1. So these are 8 possible dk minus 1, dk2 combination. And for each such combination, we know what should be the value of vk1 and vk2, because we know the mapping or the arithmetic which we have defined here. So vk1, vk2 corresponding, we can make a table like this. So we are making a state diagram, that how the state transition occurs when your dk changes from one, and how our convolutional encoder moves from one state to another state as the input bits come in. So this is the whole purpose of representing it with a state diagram. So we can write it 1 0 0 1 1 1 0 0 0 1 1 0. So let's make a state diagram, because states are, I told you, these two, dk minus 2, dk minus 1. So what are the, how many states are possible? 0 0 0 1 1 0 1 1. So let us represent the first stage by A, the second state by B, second state by C, and the last state by D. So these are the 4 possible states. So what would happen, you will see that our channel encoder will move from one state to another according to the value of dk. So let us see. So initially, if our convolutional encoder was in initial A state and the input is 0, or input is 1, according to that, what will see? So if the input is 0, the next state is, what is the next state? This will become the next state. If you see, because dk will become your dk minus 1, your dk will become your dk minus 1, and your dk minus 1 will become dk minus 2. So you see that dk minus 1 dk, this become the next state of the convolutional encoder. These represents the next state. When initially it was in 0 0 state, input 0 comes, the next state is this one, and the output is 0 0. So how can we write it? When 0 comes, the output is 0 0 and next state is 0 0. It means the channel encoder will be there in the same state when the input is 0 and the output is 0 0. The value of the output is 0 0. So this is represents output value. This represents current input, and this is the present state, and how will be the next state. So we will be in the same state only. Next, we are in the 0 0, suppose, and the input is 1. So what is the next state? This will become the next state, 0 1, and the output will be 1 1. So if the output is 1 1, and we write it, D is our 1 1, suppose 0 1, not we take it as B, we have taken it as B, C is 0. So so the output is 1 1 and the next state is 0 1. So the next stage is when 1 comes, the next stage is 0 1, the output is 1 1. So similarly, what we do, if our initial state was 0 1 and input 0 comes, the output will be 1 0, and the next state will become 1 0. You are in 0 1 state, and the next stage become 1 0 when 0 comes and the output is 1 0. Similarly, from that table you can see, when you are in 0 1 state and input 1 comes, your next stage will be, when you are in 0 1 1 1 comes, next stage will be 1 1 and the output will be 0 1. Output will be 0 1 and next stage will be 1 1. Similarly, if you are in 1 1, or you are, suppose you are in 1 0 and 0 comes, then your next state will be 1 1 and your output will be 0 1. You are in 1 0, suppose, and your 0 comes, your next state is 0 0 and output is 1 1. So you are in 1 0, 1 comes, your, you are in 1 0, 0 comes, 0 0 1 1. So you are in 0 0 state, 1 1, and you are in 1 0, 1 comes, 0 1 0 0. So you go to 0 0 and the output is 0 0. The output is 0. Similarly, if you are in 1 1 and 0 comes, next stage will become 1 0. You are in 1 1, 0 comes, next stage becomes, sorry, we have already did this, sorry, excuse me for that. This row is like this. And you are in 1 1, 1 comes, the state will be 1 1 only, but the output will be 1 0. So this completes our state diagram. That how we move from one state to another state as our input is 0 or 1 according to that. So this represents our state diagram. This is also called state transition diagram. So next, what we'll see that we want to also see the evolvement, the how this state diagram state changes at time passes. Like so, this is for one time. You are seeing that this is snapshot like this. That if anybody says you are in state 0, 1 comes, you will move to this. Okay, but if you want to see a time with time how these states are changing, we result on one more representation that is called Taylor's diagram, which is unfolding of the state diagram with time. With time, how states will change, you will see. So next we will study the trellis diagram, representation of a convolutional encoder. So we have seen the state transition diagram. Now we'll see the unfolding of the state transition diagram by trellis diagram. So there are four possible states. You can write it like this: A, B, C, D. Okay. So if 0 comes, you always go to this table. Okay. You are in 0, 0, 0 comes, your next state is 0, 0, right? So you write 0, 0, 0, 1, 1, 0, 1, 1. So if the 0 comes, you come to 0, 0, and the output is also 0. You are in state 0, 0, and 1 comes. You are in state 0, 0, 1 comes. Your next state is 0, 1. Output is 1, 1. The next state is 0, 1. The output is 1. So you can write your, if you are in state A, output 0, 0 comes, you will go to 1, 0, 0. 1 comes, the output is 1, 1. Similarly, if you are in state 0, 1, 0 comes, you get 1, 0, 1 comes, you get 0, 1. So in your state B, what are the outputs? You are in state B, 0 comes, you go to 1, 0, 0 comes, you to go to 1, 0, 1 comes, you go to 0, 1. In you are in state C, or 1, 0, 0 comes, you go to 1, 1. Your output is 1, 1. So first I am writing all the outputs. So you are in state 1, 0, 1 comes, your output is 0, 0. 1, 1, your state is 1, 1, 0 comes, your output is 0, 1. You are in state D or 1, 1, your 1 comes, your output is 1, 0. Your output is 1, 0. First, we have written the outputs of each A, B, C, D. Just check it if I have not done anything wrong. 0, 1, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 1. So these are the four outputs corresponding to each state. Now, how these states changes? You have seen 0 comes. So this upper branch will correspond to the input current input 0. So when you are in state 0, 0, 0 comes, you go to next state 0, 0. When 0, 0 is your current input state, 0 comes, you go to 0, 0. When you are in 0, 0, your 1 comes, you go to 0, 1. It means the lower branch represents the input 1, correspond to input 1, and the upper branch corresponds to input 0. So now answer me, if you are in state B, it means 0 1, and 0 comes, what will be its next state? 1 0, and 1 comes 1 1. So the upper branch will go to 1 0, and the lower branch will come to, the upper branch will go to 1 0, and the lower branch will go to 1 1. So this is, you say that at you are in time is equal to 0 state, like this, how your states are moving. This is the whole unfolding of the state diagram. Now you are in state 1 0. For example, 0 comes, you go to 0 0, 1 comes, you go to 0 1. 0 0, you go to, when you are in 1 0, 1 comes, you go to 0 0. So 1 comes, you go to 0 0, it means the lower branch is this, and 1 1, you go to 1 1, you go to, when you are in 1 0 state, 0 comes, you go to 1 1, and 1 comes, you go to, sorry, excuse me, this was the output. When 0 comes, you go to 0 0, and when 1 comes, you go to 0 1. When 0 comes, you go to 0 0, when 1 comes, you go to 0. Similarly, when you are in state 1 1, you are in state 1 1, when 0 comes, you go to state 1 0. So upper branch corresponding to 1 1 will be 1 0, and the lower branch, if you see, will be 1 1 1 1. This is the state transitions, okay? Because we have written all the outputs here, we are now only visualizing the state transitions. So the lower branch, the lower bottom branch corresponds to 1, the lower input, lower bottom branch corresponds to input 1 as 1, and the upper branch corresponds to input as 0. So this we have seen. Since we have written output here, we can remove the outputs from here. In the next state, similar will happen, that if you are in 0 0 state, 0 comes, you will go to 0 0, 1 will come, you will go to 0 1. When you are in 0 1, 1 0, you will go to 1. The next 1 0 is here, you go to in 0 1, or similarly, if you are in 1 0, when you are in 1 1, you go like this. So similarly, it will continue. So this you are see, this is a unfolding of your state diagram, because in state diagram you have seen only one snapshot. But now you see with time how your states are changing, and how what is the corresponding output we have seen here, written here. So our question in the initial what we have solved, that our if our input is 11010, can we get corresponding code word using the trellis diagram? If our input is 11010, so as I said, this helps you in coding and decoding, right? So it should be simpler or easier for a reader or implementer to find what is the code word corresponding to the data word 11010. So it is really simple, and what you have to do, you have to just start following. If it is 1, go to the downward direction. Start from 0 0, because your initial state was 0 0. Now 1 comes, go to the down, because I told you that the 1 corresponds to the lower branch. 1. Then comes 1 again, so again go to the lower branch. Then if 0 comes, where will you go? This, right? Because if you are in 1 1, sorry, should write 1. You can also first make the complete. If you are in 0 1, transitions are like this. If you are in 1 0, transitions are like this. If you are in 1 1, transitions are like this. 0 0, transitions are like this. 0 1, transitions are like this. You are in 1 0, then transitions are like this. If you are in 1 1, transitions are like this. If you are in 0 0, transitions are like this. If you are in 0 1, the transitions are like this. If you are in 1 0, the transitions are like this. And if you are 1 1, the transitions are like this. Just follow the path. 1 1 0, then again 1 comes, so lower path, and then 0, so upper path. So this is the path. Now you have to write the output corresponding to each path. So if you know this is upper and this is lower, and this is the corresponding output. So when 1 comes, what is the output? 1 1. Now you are in 0 1 in this state. The lower means 0 1. Then 0 comes and the output is 1 1. And when 1 comes, because you are in 1 1 position, the output is 1 1. We start again. 1 corresponds to 1 1. Then you are in 0 1 state, and 1 comes. 1 means 0 1. Then you are in 1 1. 0 comes upper, means 0 1. This point is clear, I hope, because 0 is this, comes from here. This corresponds to 0 1. Then 1 comes again. Then 1 comes again, and you are in 1 0 state, and 1 is 0 0. And then again 0 comes. You go to here, and you see it is 1 0. So now you see the code word corresponding to your data word. This. So this unfolding of the diagram, state diagram, makes little simple how to get this. And in the decoding also, we'll see how this Taylor's diagram help us in decoding of the convolutional encoder, convolutional codes. So what we have seen till now, we have seen the state diagram. The convolutional encoder has a memories, and we have seen that how to unfold the state diagram and find Taylor's diagram, and how to use this Taylor's diagram in order to find a code word corresponding to a data. Next, as I told you, I will tell you just about the code tree at the last. So what is code tree? Code tree is also help you to get what is the output word corresponding to your input word or message word. Output word is code word. But it's a little different, the code tree. In code tree, what happens? We start with 0. The fundamental is the same here. We start with here. If 0 comes, the output is 0 0. If 0 comes, the output is 0 0. If 1 comes, the output is 1 1. Similarly, you move to the next state. This is a different way to analyze the encoding scheme using the convolution codes. And there is some relation also, like the trellis codes. Trellis diagram can also be obtained using the code tree if we just combine the two similar nodes. So that is a, I mean, they are connected, but I'm not explaining it in more detail. You will study it in a when a separate course on control coding if you are taught in the future. So let's, excuse me, I have to make it again. So in code tree representation, we start with this. 0 comes, the output is 0, 0. 1 comes, the output is 1, 1. Again, your current state is now 0, your input is 0. Now, if your 0 comes, then you are in this stage. 0 comes and 1 comes. When your 0 comes, the output is again 0, 0. And when 1 comes, the output is again 1, 1. Because the states are the previous bits, right? 0, 0 only. So this represents state, right? Sorry, I have to. So your 0 comes, your output is 0, 0. Again, your 1 comes, the output is 1. Now, your this is your input 1, and the next input is, for example, you are in, you can understand it like this. If I am that the initial states are 0, 0, 0, right? The 0 comes, now the initial states are, now how many decay? This is your decay, dk minus 1, dk minus 2. You say 0 comes, it means now your 0 will become dk and this will shift. So last 3 states we will see, last 3. So now 0, 0, 0, 0, 0, 0, and again if you start 0, 0, 0, because 0, 0, 0 gives you 0, 0 gives you always 0, 0. In code tree, the way is little different. That if you start like this one, you see only last 3, 1, 0, 0, 1, 0, 0, always give you 1, 1. So this is the way in code tree. We start, suppose for example, all the states were 0, 0, 0 comes. So now your current states will become 0, 0, 0. Again 0 comes, your current states are 0, 0, your previous state is 0, and the last dk minus 2 is 0. Now when again 0 comes, you have to see only previous 3, 0, 0, 0. And what are the corresponding output? 0, 0. So that is why I write it like this. That 0, 0, 0 correspond to 0, 0, 0, 0, 0 correspond to 0, 0, 0, 0, 0 correspond to 0, 0. Okay. So next you will see that your 1, 0, 0 correspond to 1, 1. Then again if 0 comes, 0, 1, 0, just see 0, 1, 0 correspond to 1, 0. 0, 1, 0 correspond to 1, 0. 0, 1, 0, 0, 1, 0 correspond to 1, 0. No, sorry. We have to see 0, 1, 0 correspond to 1. 0, 1, 0. Oh, sorry, it should be 1. 1, 1, 0. 1, 1, 0 correspond to 0, 1. Similarly, when you are in stage 1, you have written that 1, 0, 0 is 1, 0, 0 is 1, 1. Now you say 0, 1, 0 and 1. So 0, 1, 0, 0, 1, 0, the output is 1, 0. And 1, 1, 0, 1, 1, 0, the output is 0, 1. 1, 1, 0, the output is 0. So if you make this table like this, you will see the next will be 0 1 1 1 1 0. We have already make it, so just do this exercise at your home. So you will see that in this way you can make this whole tree. 0 0 1 1 1 0 0 1 0 1 1 1 0 0 0 0 1 1 1 0. And now you will realize that whatever are the outputs of these tree, these branches will repeat itself. And the reason is very obvious. If you see that our channel encoder is this, so our current output only depends on your previous three states. So whatever was the state at the fourth time instant will not affect the outputs. So if you see, you will come from here 0 0 0, or you go from, so this stage does not affect these states. You can understand it like this: 1 x dk minus 2 dk minus 1 and dk, and 0 dk minus 2 dk minus 1 dk. So because the output only depends on these three, before this time t is equal to 0, for example, what was the bits before this does not affect your output. So it is happening like this because you are seeing only three, right? As I told you, 0 0 0. So only three. So what was there in the here in the fourth stage, if this is your current stage, second, third, what was there at the fourth stage will not affect the output. So if you see this as a whole, the output is same. The fourth at the fourth time instant, the input bit at the 0th time instant does not affect its output. That is why there will be symmetry. So whatever output you are getting here, you will get here. Just think about it, and also go through the book BP Lati. Then I think it will be more clear. So this is the, and now how to get a code word using this code tree. So this will be doing the next class because time is over. So what we have done today, we have seen the convolutional codes, that is memory. The constraint length is n, and that is equal to the number of shift register. L is equal to value L represents the modulo 2 adders, and the code rate of a convolutional encoder is 1 by L. And we have seen the state transition diagram, trellis diagram, and code tree for the uh, our convolutional encoder. And we will in the next time we will see how to get any code word using code tree, and we will also see how to decode our convolutional codes using the trellis diagram. This is very important because I told you the trellis diagram is connected to state diagram, because trellis diagram is nothing but unfolded version of a state diagram. And if you see, the trellis diagram is also same if you connect the similar nodes from the code tree. Just I am giving you a hint. This is not the in the syllabus, but trellis diagram is also connected with the code tree. So this is will be it for today. And if you have any query, you can ask.